So we go on to my number 11 moon, Miranda. This is one of the moons from the planet Uranus. It's actually the smallest object in the solar system that's round. If it was much smaller, it wouldn't have enough gravity to make itself round. But it's interesting that when you look at it, it looks like it's been smashed to pieces and it's all come back together again. You can see they're all just regular pieces of rock. It doesn't look like anything you would think would have all been made together. And I think that's maybe what's happened. It's been hit at some time so hard, it's smashed the whole moon to pieces, but the gravity has pulled it all back together again. So it's like a great big jigsaw puzzle. My next moon, number 10, Ganymede. Ganymede is one of Jupiter's moons. It's the largest moon in the solar system. It's much bigger than our moon.
Is this like a light year away?
No, this is just a hop, skip and a jump. It only takes you about 12 months to get to Jupiter, 12 months to 2 years, something like that. If you pick it right. So it's considerably bigger than our moon, as you can see. It's the largest moon in the solar system. They think it seems to be made largely of half rock and half ice, and it appears about 200 kilometres beneath the surface. It seems to have an ocean of water underneath. And you'll see later, it's not the only one that seems to have an ocean underneath the surface. But the interesting things about Ganymede, if you look at this picture, you can see it's got craters, sort of like what the moon has, but it has all these unusual lines right across the surface. Most of this is ice. So you're looking at grooves of some sort in ice.
Shouldn't this like enough light year away?
There isn't any. Well, there is, but we would never be able to detect them, not yet. Now, if you look at this, it's interesting, you can tell on this which section is younger than the other, easily. You see this area's got masses of craters in it. You see it's got a few lines through it, but it's got lots of impact craters. And this section has very few. So obviously what's happened, this whole area has been like this, and then something's happened on the surface, or in this moon. They think it's some sort of heating from the gravity or something from Jupiter. It's melted the surface, and it's flowed. So something's happened and part of this surface has flowed, it's melted.
I think there was a fire.
And all of these craters have all melted in this area. And so this is much, much newer than this. But by newer, this could be a couple of billion years, and this could still be a couple of billion years. But it could be millions of years younger. So something's happened and the surface has melted and it's flowed. And then meteorites have impacted the surface again, basically reset it, and it's got new craters on it.
Probably some ice and rock were floating through and then it suddenly just got stuck together.
Now, some of the impacts, if we look at the surface here, they've actually made ripples in this ice. I don't know if you can see, there's a sort of faint outline of ripples, like on a lake when you drop a stone in. So we've got this is a fairly recent impact. And then this is a much older one. You can see there's been an impact here, it's flattened everything, but the rim that used to be here has all been worn away because other meteorites have hit it. And it's worn the rim away. If I draw in roughly where there's sort of ripples, when I take it away, you can make out there's a faint sort of hint of ripples around here. So it's like this meteorite has hit the surface, it's maybe partially melted it, and these ripples have flowed out, and then the surface is remelted again, and you can just see the remainder of these ripples in the surface of the moon. Number 9 is Prometheus. Prometheus is what they call a shepherd moon, and it's in the F ring of Saturn. You can see little Prometheus here, and there's all the little rings in the ring system, and then there's another tiny little ring out here. And a little Prometheus, if there's any little bits of dust make it into this little gap, Prometheus comes along and flicks them away. Or they get stuck on his surface. So Prometheus is really tiny. Would be perhaps, I haven't got a scale model, maybe 2 or 3 millimetres across at this sort of scale. So a little bit bigger than a pinhead, but still quite small. And you notice the surface, you can sort of make out there's craters. You can see the little dimples, but they're all covered over. That's because as it goes through the dust in the rings, picking it all up, these little bits of dust fill in all the gaps. And so they hide all the craters that were on the surface. And so you can see there's obviously impact craters on there, but it's all covered, it's all dusty. Now how it does this, the orbit is what they call eccentric, which means that at one point it's further from Saturn, and when it comes around the other side it's closer. And so it goes around in this orbit from slightly further to slightly closer. And in the ring, if there are any particles here that were sort of drifting in towards Saturn, Prometheus would come along and either knock it back out or it would get stuck on the surface. And remember, the whole thing, all the rings and everything are rotating. So this is just like a continuous series. So it doesn't just patrol one bit, it wanders around the whole thing. So any little bit of dust gets in the way, it just knocks it back out and keeps that whole area clear.
Why doesn't it keep it clear?
That's just what it does. The laws of physics have put it into that orbit, and the laws of physics have just resulted in the fact that it cleans all this mess up. And because the rings are quite narrow, it looks like a bit of a flying saucer because all this dust hits the edge of it. And you can see it's built up a ring. So this is the bit that ploughs through all those little bits of dust in the ring that are in the road, and it's just built up this layer to make it like a flying saucer because it cleans it all up. You can see here, this is Prometheus here, and as it's come close to this ring on one of its orbits, and it's pulled away, and its gravity has just taken a little bit of dust with it. And then a previous time, when it's come around a previous orbit, it's done the same thing. You can see the dust that's been disturbed. It's pulled a little bit away, it's gone around Saturn. When it comes back to a slightly different spot because the rings are rotating all the time as well. Everything's rotating. And so it continuously pulls these little bits of dust out. And then, of course, when it comes around, it'll plough through some of these little bits of dust and pick it back up, or it'll knock it back in again. And the gravity will pull some more back out. So it's constantly shuffling things in and out of the ring all the time with gravity and impact each time it goes around. Well, number 8, I'm not going to ask any questions. Right, number 8 is Phoebe. And Phoebe orbits Saturn. They think it's actually come what they call the Kuiper belt. So it's made of similar stuff to what Pluto is. But it's very, very tiny. At that scale, that's how big Phoebe is. You can see, even compared to our moon, it's about the size of a pea in comparison to our moon. So it's a very, very tiny moon. It's only a couple of 100 kilometres across. It's very dark. It's as black as soot. So it's black like that little sample of mine. So it's very hard to find. And it's got this huge crater. And you see this huge impact crater on the end of it. These walls are about 16 kilometres high, higher than Mount Everest. If you could pick Mount Everest up and put it inside this crater, Mount Everest would just make it to that little white dot there. And the walls of the crater would tower right over Mount Everest. And because it's so tiny, the gravity is only 1/200th of what it is on the Earth. So what you could do, you could stand on the edge of this 16 kilometre high wall and you could jump. And it would take you 15 minutes to reach the bottom because the gravity is so gentle, it will just accelerate you very, very gradually. Not like if you jump off the roof here, you hit the ground very quickly because our gravity is so great. It would take you 15 minutes But of course there's no air, so you're not going to slow down, so you'll just get faster and faster as you fall. By the time you get to the bottom, you'll be doing 140 kilometres an hour. You're going to die. Because there's nothing to slow you down, so you'll just get faster and faster. Until then, the first few minutes is great. Unfortunately, that's where the story ends. Now, in 2009, they discovered something about Phoebe as well. If we were to take Saturn and its rings and shrink it right down to this size, so that's the actual size of Saturn and its rings, they found another ring system around Saturn, many, many times bigger than the rings of Saturn that we can see, but very, very dark. You can't see it from the Earth at all. They could only get that because Cassini was out there, and Cassini was very, very close, and so he could detect this ring. And they think what's happening, Phoebe actually orbits right around the outside of this dark ring. And they think the material from Phoebe, as it gets impacted by little micrometeorites all the time, this black dust is being blasted off Phoebe, and it's formed this huge ring system. So it's made of the same material. It's little bits of Phoebe that have been blasted off. And then just inside here, on the inside, is another moon called the Apis. And what it's doing, as the dust comes in, it comes along and it sweeps it all up. And we'll talk about what happens to the Apis later. That's one of my higher moons as well, for this very reason. But if we could see this ring with the naked eye, and we can't, we can just see the planet. Right? The planet to the naked eye is just a dot that looks like a star. But if we could see this ring around it, it would appear to be twice the size of the moon. So if we could see this, you would see a little yellow dot and a huge ring, twice the size of the moon, would actually be about that, would be about that size, around this little yellow star, which is Saturn, because it's so big, 26 million kilometres across.